Hey gang, welcome back to another installment of distance learning. Looking at geometry, and we've been looking at two-dimensional measurement called area. We've looked at several shapes. We looked at the parallelogram, which is just base times height, triangle, which is just half the base times the height. Then we looked at recently the trapezoid. So we finished up on the trapezoid. You have a couple days on that, and again we've been using area is equal to 1/2 the height times base 1 plus base 2, and you guys got pretty good at that. We're going to add on to our shapes today. We're going to look at the kite and the rhombus. So the kite and the rhombus, we're going to mention these at the same time because they do have the same formula. So that's why I mentioned them at the same time. We're just going to remember a few things about the shapes. So this is a kite right here. Again, it's got two pairs of consecutive congruent sides. And basically what we'll be using in these are the diagonals. So remember that you're always going to have a long diagonal and a short diagonal in a kite. Things to remember that we're going to be using. First of all, you have to remember that they are perpendicular to one another. Okay, which makes some right triangles in here. You'll see those. Also, you want to remember that the long one bisects the short one. So that means this half will be the same as this half. The red one, or the long one, is not bisected, just the short one is by the long one. Over here, this is a rhombus. Again, a rhombus is a quadrilateral with four congruent sides. And again, this is going to have a long diagonal and a short diagonal. Things to remember about your diagonals in your rhombus. Again, they're going to be perpendicular as well, which means you're going to make right triangles. Also, each of them is bisected. So again, the long diagonal will be cut in half, and the short diagonal will also be cut in half. That'll help us figure out some of these problems then. So looking at the formula for the area of these guys. So the area of these, again, we're going to use those diagonals that I have drawn up there. The formula goes like this. It's 1/2. It starts with 1/2. And then it's D1 times D2. D, of course, stands for diagonal. Now, it doesn't matter which one's D1 or D2 because you're multiplying. Remember, the order that you multiply things doesn't matter. 3 times 5 is the same thing as 5 times 3. So it doesn't matter which one's the diagonal 1 or which one's diagonal 2. You're just going to multiply them and take half, basically. So let's take a look at an example here. So here I have a kite. I don't have the diagonals drawn in, but I can use these measurements to kind of interpolate what those measurements are going to be. So this 15 is this long diagonal here, and then this 8 is this short diagonal here. So I have everything I need. So my formula, remember, is area is equal to 1/2 D1 times D2. Where D1 and D2 are just the lengths of the diagonals. So if I plug in the measurements that I have here, area is equal to 1/2, and then I just insert my measurements of my diagonals, which is going to be what, 15 times 8. So I would just plug it in the calculator like that. Just use 0.5 for the half. And so you do 0.5 times 15 times 8. And so the area inside that one is going to be 60 square units. So area is equal to 60 units squared. So that's how many squares would fit on the inside. So down here, now I have a rhombus. Now notice that I don't have the whole diagonal here. I only have part of it. But remember that both diagonals are bisected. So if this half a diagonal is 12, that means this half a diagonal over here is also going to be 12. Which means that whole diagonal is going to be 12 plus 12, which is 24. Other diagonal, same thing. I have half of it is 10. If diagonals are bisected, that means this other half is also 10, which means the other diagonal is going to be 20. So using the same formula, because it has the same formula as a kite, area is equal to 1/2 D1 times D2. I would just put my diagonals in there then. One was 24, the first one I found. Then the other one was 20. So like I said, I would just put it into the calculator just like that, using 0.5 for the half. So I'd do 0.5 times 24 times 20, which works out to be 240. So that is 240 square units, whatever the units are. 240 units squared. So you're going to have some homework problems like those. Also, in the homework, you're going to have what I call these working backwards problems. Working backwards problems are where you know the area. So notice here on this trapezoid, I know what the area is. Then I'm always missing one of the dimensions. So for this one, since it is a trapezoid, I'm not going to use 1/2 d1 times d2. I'm going to use 1/2, or area is equal to 1/2 the height times base 1 plus base 2. So area is equal to 1/2 height times base 1 plus base 2. So once you have a formula written, you can fill in what you know into the formula. So that's just the area of the trapezoid we worked on the last couple of days. And so I know what B1 and B2 is. So this 6 I can put in for B1, this 14 I can put in for B2. The area I know is 70. The only thing I won't have to know is that height right there. So let's see what happens. And we're going to use a little algebra to figure out what's going on here. So the area we said was 70. That's going to equal 1/2. The height we don't know, but I do know the bases. What were they? 6 and 14, I think? Yeah. 6 plus 14. So I'd add the 6 and the 14, and that's what, 20? Because they're in parentheses. So I'd have 70 is equal to 1/2 the height, which I don't know, times 20. Well, this 1/2 and this 20, I can multiply those. So I take 1/2 times 20 is what, 10? So this ends up being 70 is equal to, again, half of 20 is 10. So that's going to be 10 times h. So then algebraically speaking, all I got to do is just divide both sides by 10, and I end up with a height that's equal to 7. So again, I call that working backwards because I knew what the area was. I was just missing one of the dimensions. So that's a trapezoid one. Over here I have a kite. Again, I have the area here. I know it's 64. I have the one diagonal 16. I'm just missing this diagonal here. They only want to know half of the diagonal right here. So basically what I'm going to do is I'm going to find how long this whole thing is, divide it by 2, and that'll give me what they want. So formula for this is area is equal to 1/2 d1 times d2. So write the formula first, and then write in what you know. I know the area is 64. Not calculating that. I know what one of the diagonals is. Doesn't matter which one's D1. I'll just use 16. And then I'm searching for that missing diagonal. So again on this, I would just take 1/2 of the 16. Half of the 16 is 8. So 64 would then equal 8 times d. Which means when I divide by 8 both sides, that means the diagonal is equal to 8. Well, since that diagonal is equal to 8, again, that x was only referring to half of it. So that means I just take half of the 8. So again, this whole diagonal I just found to be 8. So half of that would be 4. So x is equal to 4 on this one. All right, so your homework problems are going to have problems like that. Again, you're going to be using 1/2 d 1 times due to. It works both on kites and on rhombi, like the two example problems here. And then you might have some working backward problems that'll put it in at the end. Again, you'll know the area and you'll have to find the missing dimension. So look for that, submit that to me, and as usual, email me with any questions. Again, this was just a continuation of the notes that we started the other day, but we didn't finish, but I'll still put them in the folder for you anyway. All right, I'll see you soon. Thank you.